I'm Alan Berkowitz. I'm the head of the education program here at Cary Institute. I'm trained as a plant ecologist, trained at Cornell actually, and I've been running the education program at Cary for, what is it now, it'll be 37 years in July that I have been full-time at Cary. So I'm an old timer, but I'm delighted to be here. And Data Jam is one of my beloved activities, and it's really great to hear people like the three of you, and I guess we have more, each really kind of interested in getting your kids into data and really empowering students so that data isn't swamping them, but they're using data to, understand and accomplish what they want to accomplish. So power to the data explorers and data proficient, data literate people. Carol, do you want to welcome? And we're having people say a little bit about your teaching situation, school, what your connection is to Data Jam, and then we'll jump in. So. Carol, are you?
Oh, yes. Yeah. Sorry, I was trying to connect my headphones. Can you repeat your question?
Yeah, well, just if you could just introduce yourself, where you teach, and
yeah, hi. I'm an associate professor of science education at Temple University, and I teach science education methods for our early childhood education program.
And Freddie, we just looks like Freddie GP just joined us. Introduce yourself and say a little bit about your connection to teaching in Data Jam. Or we don't fully have Freddie yet.
I might need to follow up in the chat, but I would say carry on, Alan, though.
Pardon me?
I would say carry on. I'm not sure.
Okay, so I decided to just kind of jump right into data exploration with you folks. And we're going to go back and forth between me showing you some stuff and then you doing some stuff. And you're going to be working individually. We're a small group, so we decided that each of you could benefit probably from trying out the moves that we're going to be talking about in working with data. And so you're going to be going back and forth between the instructions that are going to be in the PowerPoint that I'm going to share with you, or excuse me, the Google Slides deck. The data set that we'll share with you that's in Google Sheets, and then a Jamboard to collect your thoughts. So that's our plan, and I'm going to go ahead and share my screen and share my slideshow. Oh dear, what did I just do? Share screen 2, share. Okay, and here's my slide deck. So here we are. Ashley and I are happy to be running this. Here's our agenda. I don't know if we're gonna, I'm hoping we can make it through all these steps, but we'll see. We have, just hearing where you're all at, you're at different places, but it sounds like some of you are just getting started. I think this is a very appropriate plan for those of you just getting started, but I think there'll be something in this for everyone. So we're gonna spend a little bit of time just thinking about what do we know about the topic of the data set that I've selected for us to work on today. And then we're going to go through these 4 steps, getting your data ready, and then 3 different ways of looking at your data to make sense of to see what interesting patterns or questions you can answer. And so again, each of you is going to have a chance to do each of these, although step 1, I'm going to step one I'm going to do, but steps 2, 3, and 4 you're each going to have a chance to do once I give an introduction to it. So that's the plan for this afternoon, and so I'm just going to jump right in, and so your PowerPoint or the slide deck that you have, which Ashley I think is sharing the link to, has these slides, and this is where you'll find your instructions. So I've decided that we would use this data set, the tree canopies and precipitation in a forest data set. And I think that I will show you now that even though I said that so this is the way I find myself is I go Hudson Data Jam. And so here we are, Hudson Data Jam, and presumably you all have already done this, but this is how we're going to find the data sets. So we go to Hudson Data Jam, we go to data sets. Since you are teachers, I decided to, and I didn't know what your backgrounds were, I decided to choose a challenging data set. So that might have been, I hope that that's going to work out okay. So down here in level, you can select challenging. That kind of filters out just the challenging data sets. And then I chose this tree canopies and precipitation chemistry in a forest data set. One of the reasons I chose this is that it contains data that was collected here at Cary Institute. So we're a small research institute in the Hudson Valley, and we study places for a long time. So we've been studying our tree canopy here for a long time, and we, through Data Jam, we're sharing that data with you and students and the community. So I thought it would be fun to use one of our, very distinctive to Cary data sets, and I think it's a totally cool data set. So I'm excited to be teaching about it. And so I want you to go to this data set, and I'm going to just turn this over to you. I'd like you to work your way to this page, and this is what each data set page looks like. There's a link to the data. There's a link to metadata, which is information or data about the data. So that explains how the data was collected and what the different variables, what the measurements mean. There's also background information and a little bit about the sampling location and the methods. So what I'd like you to do is, so just to go back here, this is, since maybe you're not familiar with the idea of throughfall, so precipitation falls everywhere on the Earth's surface, and that's called precipitation. And then the water that makes its way through a tree canopy is considered throughfall. So here we are underneath the tree canopy, and here's a funnel, and you can't see it that well, but there's a bottle in there inside this milk crate. And that bottle is collecting the water that makes it through the canopy and lands on that funnel. And the data that we have is for the amount of water and the chemistry of that water every month for about 7 years. So that's the data, that's the throughfall data. And then we also have data collected in a similar way, but out in the open. So that's not throughfall, it's straight up precipitation chemistry data. So what I want you to do now is I want you to go to the Jamboard, and I guess I'll show the Jamboard. The Jamboard looks like this, and the first page of the Jamboard, and Ashley, I think, is linking you to the Jamboard. So the first page is just to collect some of your thoughts about what do you know and wonder about the kind of topic that we're going to be exploring. Precipitation, precipitation chemistry, throughfall. What are some things that you already know about, or that you wonder about this topic? And you can, if you're not familiar with Jamboard, you can choose over here on the left a sticky note. You get a sticky note and say, and maybe you want to put your name, or you can leave it anonymous. What is in rainwater precipitation? That might be one of your questions. So you post that, and then we have a, that's a wonder. Okay, so I'm going to give you a few minutes to look at that landing page. I'll pull the landing page back up, since you should have a link to the Jamboard. So the landing page looked like this, and here's the background information. So what are some things you know or wonder about this topic? And go ahead and put them on the Jamboard. And at any time, feel free to fire some questions onto the into the chat. Wow. You're asking some really great questions. This is really cool. Mhm. Mhm. Okay, one more minute, and then we're going to jump into the next part. Wow. So you folks are asking some really good questions, some of which you'll actually be able to answer, at least in part with the data that we're going to be looking at. Cool. Ashley, do I have the, can I go to the next part?
I think so, yes.
Okay, so here we are, slideshow. So we've seen some really interesting questions about acid rain, about nutrients, about different the possible effect of different features of the canopy, different tree species, different heights of the canopy, different ages. So these are all shows that y'all are thinking maybe different than your students. In other words, your students might not have these level of sophistication of questions. They might have a hard time even thinking about through fall if they've never really thought about through fall before. And so that's the kind of thing, again, in the spirit of helping you help your students get into this, this is the kind of thing where some of the data sets, you really need to help the students just get a concrete feeling of what we're talking about. So you can even do things like get a plant and spray it and see what happens when you spray and spray and spray. And they can actually make some pretty interesting observations right there with the potted plant, and spraying and spraying and spraying until the water starts dripping off the leaves. So you get the idea of the canopy maybe holding some of the water and then the water coming through. So you can help your students make these things concrete in that sort of way. So now we're going to go on to part one. And part one, I'm going to do the most talking, I think, about will today. So because you need to get your data set ready. And not necessarily at first. At first, you might want to just jump in and not fuss about making your data set ready. But when I went into this data set, I was a little frustrated. So I felt like I needed to, I needed to get it ready. And so I'm going to show you, if you hit this through fall and precipitation chemistry, that's how you get the data. Okay. And the data set that you get, I'm not going to do the link because I kind of have things kind of ready for this webinar. And hold on, give me a second. So this is what you get when you download that. You get 3 worksheets. You get a through fall data worksheet, a through fall data average worksheet, and a precipitation data worksheet. This is a Google sheet that you'll get. And what you'll do with your students, you won't have editing access to this when you click that. And you might want to request editing access, but that's not the way we're set up. We're set up for you to download this and then work with your downloaded version. Okay, so that's what I did. I downloaded this and then saved it with its own name, which I called AB Working. And this is actually a copy of it. So it's copy of blah, blah, blah with AB Working. That's me. I'm Alan Berkowitz. That's how I name things. And these are the data as I downloaded them. So I looked at this and I say, when I'm working with a data set, eventually I like to have just these variable names at the very top of the columns and not all this metadata here. So the metadata is useful, but I didn't want to have it there messing up my data set. So I'm going to take that out and put it in another place. So I still have it, but it's not messing up my data set. I also noticed that the through fall data starts in 1993, but the precipitation data starts in 1984. So I've got a bunch of precipitation data that's not going to line up with my through fall data. So I don't really need it all. Now, if I just want to look at the precipitation data and didn't want to mess with the through fall data, I might be happy with all that extra precipitation data. So this is kind of an example of the messiness of real data and also what you're going to find with the Data Jam data sets. They're not all like completely, absolutely ready to just jump right in and start making graphs. You have to think about some cleanup. And in this case, so I made a new version of these data that I will show you by going over here. And I made, I brought the precipitation data over, but only from 1993 on. And I brought the through fall data over that I needed. And then I actually brought the metadata all over and created a different kind of metadata file. And remember, metadata is data about the data. So this is the data source, where it was collected, the methods, what data is shown, and any manipulations that you did. And this is where I made a record of, hey, I removed the metadata from the top of the worksheet and I have my initials there, so I know what I did. Here's the through fall data. And then I created this new data set, which is the one you're going to be working with, called TF versus PCP data. And this is now clean and ready to go. Okay, and so I'm not going to have you do that because this takes longer than we have time for. And I've done it for this data set already. So this is the data set that we're going to work with. So the other thing I wanted to note, if you look over here at the through fall data, for the first couple of lines in this through fall data, you notice that it starts in the middle of a month and ends in the middle of a month. Whereas our precipitation data is just by the month. So again, these data aren't going to line up with my precipitation data. So what I ended up doing was I ended up hiding until starting in August, the data in August is now on a monthly basis. So over here in my combined data, you might notice it starts on line 9. What's going on there? Well, I hid the first 7 lines of data. And you can see that by hitting that little arrow, and there they are. But I do, in fact, want to hide them. So I'm going to go back and hide them. And once you hide them, they're not used in any calculations you do with the data set. It's a really nice feature of Google Sheets. And just as a little plug, I'm not super proficient at Google Sheets, but I learned a lot of what I'm showing you just in the last few days getting ready for this webinar. And I'm saying that not like, oh, how smart is Alan? I'm saying that it's really a pretty user-friendly. And anything that you don't know how to do, I don't even bother with. I haven't used the help in Google. I use Sheets. I use the help just by going to Google. How do I do this? And you just say, how do I sort things in Google Sheets, or how do I hide things in Google Sheets? And you'll find the help that you need. So here's our data, and again we have precipitation data, and I had to go and add PCP after the precipitation data columns, and I had to add T-fall for the through fall data, so that I'd be able to keep track of which ones were precipitation and which ones were through fall. You might be tempted to say, well, I'll remember that the ones in the first columns are the precip and the ones in the second set of columns are the through fall, but it's really a better idea to get things labeled. And what's not shown here, which if you're a fussy science teacher, like you probably should be, are the units. So we have the units for the precipitation, that's in centimeters, but we don't have the units for all these other things, and those are all milligrams per liter, and that will be in the metadata. So if you go over to metadata, and you see here it says data notes, it says mean concentrations, milligrams per liter of the following ions: hydrogen, calcium, magnesium. So that's, you should always be able to find what are the units. And depending on how fussy a science teacher you are, you could kind of say, hey, Alan, you really should put the units in each of these headings, right? So that you could come in here and put milligrams per, milligrams per liter. And show that as wrapped so that you can see it. So this is all in the spirit of cleaning up your data and getting it ready to go. So I'm going to stop and see if there's any questions about this step. And you can type them in the chat and Ashley will pick them up, or you can just unmute and shout them out. the first step you will do the first step you will do when you start working with the data in the next part here is you're going to make a copy of the active worksheet so that the actual active worksheet stays as an archive version. So Ashley's going to give you a link. Did you give them the link to the spreadsheet, Ashley?
I just put it in the chat.
Okay, and that's this version, which doesn't have quite as many things. I simplified, I took out some of those worksheets that we don't need. So now you're coming into a worksheet, into a spreadsheet, and you want the TF versus PCP data worksheet. And before you do any kind of manipulations or stuff, you're going to make your own version of that worksheet. And I'll show you how to do that right now. So here we are in TF versus PCP data. So this is this nice, clean, ready to go worksheet. I'm going to right click it and make a duplicate. And that gives me this new worksheet called copy of. And instead of that, I'm going to rename it to, I'll put my name at the beginning, Alan's. So now I have my own version. The original version is still here. My version is here. If I mess it up, I can go back and make another copy of the original version. This is a really good practice for your students they've downloaded something, they want to have a version that they can work with, but also a version that is kind of archived. If you want to be really fussy, you could protect the archived version so that you can't accidentally mess it up, but we're not going to go that far. So now I see Anne has a version. So I'm going to jump back to my slides. We've demonstrated that. So now we're going to jump to part 2. Let's see what part 2 says. What can I learn from looking at one variable? Okay, so we're going to use this data set. And actually, I'm going to demonstrate and then let you have at it. So here's what I mean. So one way to get to know a data set is just see what are the numbers. Before you try to jump right at looking for lots of patterns and relationships, and this is one approach to entreeing into the data. And I'm going to take you through it. You could decide, I don't like this so much. But so one approach is let's just look at one variable at a time. So for instance, I'm really interested in just rainfall. Rainfall is something I actually feel like I know some more about than throughfall. So let's see if I can understand what can I learn just from looking at rainfall as a single variable. So I look at the rainfall here, monthly precip, and what are some of the things that I might want to look at? Well, Google, let me make sure. Oh, I have this. Yeah, this is a shame. So I'm going to use the. That's the problem. Actually, is I have these things. I'm going to get rid of them. That's going to mess me up later on, but that's okay. So I'm going to select this column, and then I'm going to go under data. I'm going to hit column stats. Is a nice feature of Google Sheets, and column stats. Oh boy, I got to move my. Okay, so here's what you get when you hit column stats, and the top thing is a diagram, and this is useless. This version, but if you hit the distribution version, you get a graph like that. And to me, there's lots of information in this. This is monthly precipitation for our 7 years, 5 months worth of data. And these are centimeters. So, 25 centimeters, 29 centimeters, that's a foot, right? So that's a lot of rain in 1 month. And so this is one thing that you can look at is the distribution. And again, you get to that by clicking this distribution. If you also, and then if you go down, you can see, well, what is some other things I can see down here? I can see what the average is, 9.31 centimeters a month. The median is 8.37. Somebody want to chime in? What does it mean that the median is lower than the mean? Anybody have an explanation for that? You can unmute and shout it out. So remember that the median is the middle data point. Half the data is below it, half the data is above it. Whereas the mean is the average of all the data points. And when you have a distribution that looks like this, where you have a few really high points and a bunch of really low points, the median is going to be pulled down by all those low points, whereas the average is going to be pulled up by those few high points. So that's why the average is higher than the median. It's quite a bit higher. It's like a whole unit, a whole centimeter more. And we have this huge range. 1 month, only 0.8 centimeters of rain fell in a whole month, right? And in 1 month, we had 26 centimeters. So, so what I'd like you to do now is, by way of getting to know the data set, I'm not going to tell you what variable to work on, but I want you to pick a variable and get to know it and see what you can see about it just by the way I just showed you. Pick the variable, highlight the column, choose the under data, choose the column stats, and then type something about that variable in the next data Jamboard. So we have a Jamboard for this, and in your post-it, type the variable that you looked at, something you learned about it by just looking at these basic descriptive statistics about it, and your name if you want. You don't have to put your name. So, and I'm going to pause and see if people have questions, because I have been talking a lot here for the last few minutes. So.
And Alan, I think a few folks may still need to make their tab with the data too.
Okay, so remember, you're going to go to this basic data set, TF versus PCP data, right click it, duplicate it, and then you can rename your data set once you've made that new one, instead of copy of, you'll go ahead and use the rename feature to rename it, okay? If you're having trouble with any of this stuff and need a one-on-one, let us know, and we can do a breakout, and one of us can go into a breakout with you for a one-on-one.
Carol, I don't know if we answered your question. I'm so sorry, I just saw it, but that is totally fine if you downloaded the file and are working with it that way. I think later, if we want, we can have you like share your screen once we've been working with the data a little bit.
Once you've discovered something, share it with us in the Jamboard. Hmm.
Now, so Alan, can you verbalize again how to make a copy of the tab within Google Sheets, like Annie
Yes,
has done?
you point at the you point at the tab label, so, and then you right click, and that pulls up the options, and the option is duplicate. So you hit duplicate, and that results in a new folder, a new tab called copy of, and then that's what you would then rename with your name. So now I have an extra one. Although I'm not in the, I'm in my other version of the data set, so that's probably confusing. So I'll close that out so that I'm only working in this one. So we have Carol and yeah, I see Carol and Ann. Oh, I'm sorry, Annie. Sorry, Annie. Yeah, someone. So we have. So we have a comment about magnesium and a comment about nitrate. So why don't we jump on? Let's look at that. Let's look at some of that together. So if we're in, let's do the nitrate first. So here's nitrate and throughfall, for instance. So I'm going to show you how to do how to make your own histogram. So using the column stats is kind of a quick and handy thing, but I don't know how to take a graph out of that and use it for something. So I want to show you how to make your own distribution diagram like that. Okay, so I'll show you that now, and then that'll be part of our next part anyway. So we're going to go to let's look at nitrate and throughfall, and I'm going to select all the data. Okay, so now I've selected the data, nitrogen and throughfall, and nitrate in throughfall. That's what NO3 is, nitrate. And I'm going to go insert chart. And sorry, I have this, you have to move me away here. And over here in my chart editor, I have it already, for me, since this was the last chart I made, it already has me in a histogram. But if it didn't have histogram, that's what you want. You would want to select histogram. And this is the same as what we saw with the chart stats, but now I can actually put this into a PowerPoint, or I can put it in a Word doc, or I can do other things with it. But I also wanted to address the question or the comment that somebody put in the Jamboard, which is, okay, I see. So if we look at these data, it says, well, yeah, so you can see where most nitrate levels are in kind of between 2 and 3. And we have some really low ones, and then we have some really high ones. Well, what does that all mean? So one of the things that's handy when you're looking at one set of data is, well, what do we expect, right? And that's kind of what you're asking. Well, water is not safe to drink if it's over 10. So, and that's that. So polluted water that is not safe to drink with respect to nitrogen has values over 10. So the fact that rainwater falling through the canopy is approaching that in some instances is really dirty, right? It's very, very concerning. And in the most pristine places in the world, almost all the values are down here near 0. So this is a pretty good sign that our precipitation, even when it comes through the canopy, is not as clean as we might wish it to be. This is human influenced, this nitrogen level, just based on what we know about. So we're still just looking at one variable, but now we're kind of comparing it to what we might expect, right? Same thing with if you looked at precipitation, you say, wow, look at this range of precipitation. I know that 0 rain means it's a drought, and 25 centimeters of rain in a month, that's a really wet month, right? And so and yet things like nitrogen, I don't have any wisdom about magnesium. So I couldn't tell you what I just told you for nitrogen about magnesium. I would have to do reading about it, right? And that's what, so you never can learn everything about, just by looking at the data. You have to be a scientist too. You have to bring what we know about magnesium or nitrogen to the table. Your kids are not going to be able to tell an interesting story just by looking at the numbers, because they need to know what the numbers mean, what might explain the patterns that they're looking at. Okay, so that's a reason why, like the people who are out measuring, what's another example, levels of toxin in food. They're just looking at what's the level, because they want to make sure it's not above it. There might be a threshold, and what percentage of the time is the nitrogen above a threshold that's harmful for the environment, that's unsafe. So these are the kinds of questions that you do kind of address when you're looking at just one variable, and what the distribution of that is across whatever your sample is. In this case, it's 7 years. Okay, so let's move on to the next part. This is okay. So comparing one variable in 2 groups. So in this case, I think one of the most interesting questions that I think is happening in this data set is which is dirtier, the rainwater or the throughfall? I think that was one of the questions that people asked in the original. I think if we went back to where was that question does canopy impact the pH? Unfortunately, we don't have pH in both, but we could ask that question for, something like nitrogen. Okay, so let's go back to our data. And here's a histogram of nitrogen in through-fall. And you can make a similar histogram of the nitrogen in the rainfall. And that is in one of these. And so I've already shown you how to do this. Over here, I can show you a trick. If you're doing histograms and you want to be able to stack them on top of each other so you can see how they compare, then you need the x-axis to be the same in both cases. Okay? So here the range is from 0 to 8.5. So if I'm going to make a histogram of the precipitation in rainfall, the nitrogen in rainfall, where is that data? That's here. Then I'm going to select this. Select that. I'm going to go insert chart and then get a histogram. But you see now the range is not the same. This is from 0 to 5 because there's less in the rainfall. But I want it to be the same. So I'm going to go customize horizontal axis, and I get to set the minimum value of 0 and the maximum value of 8.5, which is what the other one was. And now I get a graph like this. And unfortunately, I don't know how to make this easy peasy to look at, one on top of the other, except kind of clunky. So I'll show you the clunky method. Where's the other graph? Where did the other graph go? I already did it, so I'm sorry. I'm gonna cheat and not waste your time in real time and show you nitrate through fall versus precipitation histogram. And there they are. So Annie or Gian, what is this? What is this? What do you draw? What conclusion can you draw from just looking at these two graphs?
That nitrates increase as the precipitation is going through the tree canopy.
And is that what you expected?
Somewhat.
And why? Why do you think that that's happening?
Well, I'm assuming that some of the chemicals that the trees are taking up from the soil will also be found in other areas of the tree. I'm not entirely sure.
So you think that this extra nitrate in the through fall is coming from kind of up through the tree and out into the leaves, and then the rain is picking it up off the leaves. No, that's a really interesting hypothesis. Ashley, this is new to you. You have thoughts about it?
I was hoping you weren't going to call me out. I honestly don't know. I'll be upfront. I'm not sure. I liked Annie's hypothesis. And I thought that was really interesting. Well, I guess something, I don't know if this is possible, but if like there had been accumulation maybe on on the leaves, on the plants from previously. And so, you know, if there's already that accumulation on the leaves, then it rains, then maybe that would result in there being more through fall.
So these are two excellent hypotheses that we can't answer with these data, right? Or maybe that's not obvious that we can't, but I can tell you we can't answer that with these data. So it could come from the soil through the tree out onto the leaves and then down, or it could come from dust or other accumulation on the leaves. There's a fascinating, and those are both totally reasonable. And there's a fascinating third possibility, which is still kind of a hot area, which is that there could be microbes on the leaves that could be fixing nitrogen out of the atmosphere, so that there's enrichment of nitrogen on the surface of the leaves, not due to deep deposition and not due to coming out of the leaves, but actually from microbes living on the leaf. So those are three possibilities. That one's a little wacky, but there is some research showing that in some cases that might be going on. So this is a nice comparison between these two groups. It's not a statistical test, right? So if you wanted to do a statistical test, that's kind of more for an advanced workshop than for this workshop. But you could do a t-test, and actually your data set has, I think it has, unless I erased it, no, it has the t-test, and actually this is a highly significant difference. Unlikely to happen just by chance. And that's the kind of, and those results are actually here at the bottom of that column. That's what, there's a pair t-test. Since the data was collected in the same month, you can treat them as a paired sample, and or if it's treated as completely random, then it's almost significant. It's not quite as significant. That pairing really makes a big difference in this case. I'm sorry, that's the precept. This is the nitrate comparison. These are highly significant, both of them. So I don't know, is Gian with us, or I can't tell. I don't know if you've been chiming into the we got two entries, but one of those could have been from
Yeah, and Alan, they have to hop off.
what?
But I just want to say, Alan, that like several people had other things that they needed to get to as well, but we're very interested in the recording. So I think it's just tough timing, no matter what, after school time.
Yeah, I understand. So Annie, can you hang in there for another little bit?
I sure can.
Okay, great. So what I'd like you to do now is ask a question. I think it's it makes the most sense to compare, to make one of these group. Well, actually, you know what? I think what we're going to do, Annie, is we just jump right on to the final step that I'm suggesting you look at. So what we just looked at was comparing the two groups and using, we used like stacking the histograms that way. Another way to do that, which is a pretty straightforward way, is to create a graph like this. There's just two numbers here, the mean for the nitrate in precipitation and the mean for the nitrate in the throughfall. These error bars, are you familiar with error bars? Okay, so we know that this mean is actually the mean of all those numbers that we just looked at, right? And that's had that lot of variation. And so ideally, these error bars would give us a sense of how much variation there was around that mean, how consistent was the mean. And we know from from looking at these two graphs that there's a lot of variation around the mean, right? And unfortunately, Google Sheets gives you error bars, but they're not real error bars. So, and this is something I learned just the other day, because I'm forcing myself to use Google Sheets because that's what most teachers and kids have access to. But what it means is that these error bars are simply percentages of the mean, 10%. And so that's not really reflecting the actual variability. But these are what we do. And with group comparisons, it could be if we had, you would use the same thing if you had, nitrate levels in a bunch of different places, or so it doesn't have to be just two, right? It could be, these sorts of group comparisons are one whole kind of analysis we do, right? Males versus females, or young versus old, or lots of comparisons that you might make using this. So, but because the data was collected the same month and it's the same variable, we can also do this final kind of comparison, which is what we describe in part for comparing two variables, where you're actually saying, are they related to each other? So in this case, we said nitrate is higher in through fall than it is in rain. But how are they actually related to each other? Are the times when nitrate was high in through fall also the times that it was high in the rain? Or are they independent? And so that's the question that we can ask by looking at the relationship one to the other. And so the way we do that is we select two. We go back to our data, and I'm going to get rid of these because they're in my way. And we can, so we already have this data, this variable selected, and we can go over, I'm going to get rid of that one too. You're kind of, sorry. So we have that one, and we right click so that we keep it selected, and then we select this one. And now we're going to insert a chart. And this time, sorry, we're going to hit scatter. And now this is what we get, a chart that looks like that. Okay, and what we have here is nitrate in rainfall and nitrate in through fall. And that looks like a pretty good relationship. So are you familiar with the idea of a trend line? So if we go into our chart editor, and by the way, if you don't have the chart editor, if you click this, you can you can right click it and get the chart editor, or you could hit edit chart and you get it over here on the right. So we're going to customize, and we're going to customize the series. This isn't completely intuitive to me, but if you want a trend line, that's how you get the trend line. You open series, you come down here, and you see there's a trend line option. And you also see that you have a choice between what kind of line. It can be a straight line, an exponential, which goes up, curves up, a polynomial, which has a curve depending on the data, can go up or down. Logarithmic goes, well, there's what logarithmic is, a different kind of curve. And I think that those are the only ones that I would suggest considering. But let's just stick with linear. And the other things you want to do is you want to, under label, you want to hit use equation, and you want to show the R squared. So here's our data, here's our graph. And I already have this graph made, so I'm going to go to that because it's a little bit bigger. And that's this one, through fall, this scatter one. So that's the same graph, but now it's bigger, so we can see it a little bit better. So let's just, this line, the trend line, is what we call the line of best fit. And I'm going to just say this once as clearly as I can, and if it helps, it helps. If not, this is the line that the algorithm draws that minimizes all these distances from each point to the line. That's what we mean by the line of best fit. Any other line would have more distance between the points in the line than this one does. So that's what a trend line is. And the R square is actually the percentage of all the variability in the Y variable. So in this case, through fall nitrate. What percentage of all that variability does this line explain? And this is saying it explains about half, 0.53, 53%. Okay. You can ask, is that good? And I would say, well, it's better than 52%, and it's worse than 90%. There's a lot of variation in through fall chemistry that's not explained by precipitation chemistry. That should be interesting. Oh, well, maybe that has to do with the trees or the dust or these other factors that we were thinking about where the nitrate could be coming from. So the amount of nitrogen in the through fall is not, it's not like 95% of it is explained by what comes in. The trees are definitely having an effect, and they're having an effect that varies from time to time. I just love this because it means, well, we got a basic thing going on, but we know that other stuff is going on that we want to try to explain, right? This line is made worse by this point, which I didn't notice until around half an hour ago or half hour before the webinar. So what is, and I actually wasted a bunch of time seeing if I made a mistake in the way I brought the data over. So I went back to the original data, but this is a real number in the data set. But if you think about it, that's pulling this line down. And that's a huge distance from that point to this line. It's like way lower than you would predict from the rest of the trend line. So if we got rid of that one point, the R square would go up a bunch. But we don't have any reason to get rid of it. So we won't.
Alan, I mean, this brings up a good point that I think students and teachers have had in the past of like, if they see an outlier like this, is it worthwhile to explore if they took away that data point? How would that change the story? Or is that kind of a dangerous thing to do? And
well, I think like if you don't have any justification for taking it out, then the best you can do if you want to go down that path is say, if this was an error, the relationship would be such and such, but since we don't have any reason to think it's an error, then and so in other words, you can present both kind of findings, but you have to be clear that you don't have a real justification for leaving it out.
Yeah. And part of the reason I asked that too is because just so Annie knows, there are some data sets where there could be like a historical reason, like certain years or something, there could have been war going on or something that might have impacted when data was collected. And so that might be something, since your students show like there's 20 different data sets going on, it might come up.
Yeah. You can, I've been in exactly this place before, working with teachers, working with students, seeing an outlier. I've contacted the scientists, and in one case, I got a corrected data point. So if this was a high priority data set, we really wanted to, I think we could follow up with Cary and say, is this really a real number? And it might turn into a missing value, right? In other words, you might say, Alan, you're right. I think that's an outlier. I think you should leave it out of the data set. So, or there's a decimal point or something like that. So I think, Annie, I'd like to give you a chance to make your own graph like this with another one of the variables. And, we've done this for nitrate. I haven't done this. I've done it for precip, just the volume of water. I have that graph. It's one of these tabs in here. But the next one over, here's what it looks like for precip. Okay, so that's through fall volume versus rainfall volume. And that's a tighter relationship. 85%, 80 R squared is 86. And that should be intuitively really obvious that the distances between each of these points and the line are much lower than in this graph, where you have all these, especially, all these big distances between the line and the. So I'd like you to pick a variable and see if you can make this kind of comparison, and then show it to us. Okay. I'm going to step away for a minute. I'll be back.
Okay, so it looks like I forgot how to put in both variables for this.
Yeah, it's actually a little bit tricky because you have to use the control key, and Google Sheets doesn't really make it easier. So I'll show you a way to do it even easier.
Okay.
then, I mean, so if we go to the data,
Yeah, because I was gonna look at ammonia
okay,
precipitation versus through fall.
so the easiest way to do it is to go, so you got ammonia and precipitation there, column J, right? And you go over you select the intervening columns and you hide them. Okay. Then you have the two columns that you want to compare next to each other. I'm sorry. Let me show you how to do this. Maybe I'm going too fast. So you put your cursor at the top left cell that you want to be in. You hit Shift. You hold down Shift, and you kind of use your arrow keys. This is the way I do it. Use your arrow keys until you now have highlighted the two columns that you want. And then you hit Insert Chart, Scatter, and wow, look at that.
Sometimes I'll even, if I really want it super clean, I'll copy and paste, but like
Put it into a
new
different
tab,
into a different tab. Yeah, yeah.
but there's multiple ways to do it.
So this is it's a lot messier data. It's a lot messier relationship than what I kind of expected. And then again, you can go down here, customize, series, trendline, use equation, show R square, worse R square. But I checked the nitrate versus the ammonia, and that data point that had the really low nitrate that we were just looking at did not have really low ammonia, which doesn't totally make sense. But this is, so there, in this case, it's only 43% of the variability. And interestingly, the slope, so Annie, remind me what you teach.
I teach 7th grade science.
Okay, so this is, to me, it's always amazing. So kids learn about the equation of a line, but this is where it really matters. And so the slope is close to 1, which is kind of what you would expect, right? It's nitrogen, ammonia, you would kind of think that they'd go up. Now it's a slope of 1, but it's got all this noise. So that's kind of, I find both of those things kind of interesting. And sometimes the intercept, which is in this case 0.0488, sometimes that means something. In this case, I don't have an easy biological kind of interpretation of the intercept, but the slope is definitely almost always interesting in these sorts of relationships. So why don't you go ahead and pick another one, just so you can practice doing that and share and have something to share with us, okay?
And Alan, I did one, we don't have to, we can wait to talk about it, but I did one for sulfate on a tab too.
Do we have an Ashley data set? Oh, we do.
Where I decided I would practice.
That's great. Let's see your graph. Did you make a graph, Ashley?
Oh, it's down. It's down. I'll bring it up.
Oh yeah, no, I see it. I see it. I see it. Ooh, ooh, wow, Ashley. See, and in your case, Ashley, with the slope of 1.41, that's saying, you know, the throughfall is you know, is 40% more concentrated in sulfate than the rainwater, right? Even though it's actually a really pretty tight relationship, especially look, I mean, down in this lower part, it's really right. So Annie is going to share something with us in a minute, I think.
Okay, so I don't know if you can see, does my chart show up on my tab from your screen?
Well, if we let me look at your tab. So Annie's, okay. Yeah.
There it is, okay.
Ooh, chloride. Wow. So what do you make of this?
Well, it does seem like there is a bit of a correlation here, linear. Not a real great trend line, worse than the other two that we looked at. Again, I'm not sure where chlorine actually comes into play. I'd have to dig in a little bit to find out why that would make sense, because I really don't know. I just randomly chose this one.
Yeah, so I'm quite intrigued by this. So this is and you know, your students, to make sense of this stuff, would need to do some reading and research, right? And where does chloride come? You know, what's the source of chloride in the atmosphere? On the whole process that Ashley was talking about is what we consider dry deposition. And so if you knew about dry deposition, or if your students knew about that term, they could actually search on, use that term like chloride dry deposition, and they might find some information about, you know, where does chloride is I'm sorry, my dog is ready to go outside. Chloride is, you know, key part of road salt and dust. And I would think that that would be a major source. It might be really interesting to see if chloride is higher, like, you know, if these high chloride levels were in the wintertime associated with times when road salt was being, you know, or shortly after road, you know, there's all sorts of interesting questions about, and I'm quite intrigued by these high chloride levels. And so that's the kind of back and forth between looking at your data and making sense of the data. A graph like this definitely has you wanting, your middle school students, right?
Yeah.
Yeah. So, you know, when you start taking into account two variables, like you've got, if you're trying to explain this variation in through-fall chloride, well, part of it, around a third of it, or 30% of it, is explained by the precip, but other things are going on. So you know, you have data on what months of the year these, and you could look into whether there was some relationship between the months of the year and when these were taking place. In this data set, well, let's just real quickly. Now you got me thinking about this. Let's real quickly. What did I do? Let's unhide. Let's so we have. Let's look at sodium, because sodium is the other part of road salt, right? So sodium. Let's see if it shows a similarly. So and whoa, you didn't give me a scatter. I don't know why it wanted me to have that kind of. No, I got something wrong. What did I do wrong? Oh, wait a minute. Why is it doing? Oh, wait, what am I doing, Ashley?
I honestly don't know.
All right,
To get it to-
let me just make sure I don't have anything goofy. Insert chart. Why is it doing that?
It's not picking up anything on the other columns, right? No.
No, I didn't think so. I was wondering about that. It
I'm
looks
gonna
like
try it on mine.
it's acting as if I have another column selected. Sorry, Annie. We're
That's okay. Is it because you have the title selected with the data?
I
Could be.
don't think so. Let's just try one more time.
I got it to
Use
work
row
on
one as
mine.
headers. You did. Yeah,
did.
something's going wacky. So
And I
okay, show
didn't-
us.
I didn't include,
Let's
okay, you can
move.
just go to my tab and just scroll down.
There it is. That's the sodium. Okay, so then let's
And then I can insert.
okay, go on. Show off.
Okay, there's the.
Annie, what
There we
this
go.
is, oh, look at that. Look at that. So it's a slightly better R square. And then the chloride. Let me see
But
what
those points look similar up there, right?
yeah, but we don't know. So you could look at the chloride versus, I mean, you would expect a really close relationship between chloride and sodium, especially if that's how it's coming as salt, right?
Well, road salt is a lot of magnesium chloride too, right?
Right.
That
right.
could be.
So that could be another. Yeah. So I think that let me and we can, and if you have, let me just make a couple comments and then I'll any other questions that you have, and then we can wrap up. So one of my goals in doing it this way was to, I think you want kids to do what we've been doing. In other words, and one of the things that makes it possible is that idea of keeping a version of your data set that you're not going to mess up. And if you have that worksheet that you either have actually protected so that they can't mess it up, or you just agree, that version we're just going to leave there, we're not going to mess it up. I mean, that way you can get into your worksheet and you go ahead and hide columns and hide rows and make calculations, and don't be afraid of messing up, because you can always go back to your archived version. Especially in this case where I put a fair amount of work into cleaning, creating this version of the data set, where something I didn't show you that we didn't really have time, but over here, I made some new variables. We didn't talk about that whole part of that data cleaning, data manipulation step, but I created a variable that was just the difference between precip and through-fall volume, right? It's a different way of asking, and in this case, you see, yeah, precipitation is in general more than through-fall. The canopy intercepts water, and some of it evaporates before it turns into through-fall. And so in general, all these numbers are positive. How some could be this negative, meaning the through-fall was more than the rainfall, is a really cool thing about through-fall, because sometimes through-fall actually can funnel water and more can fall in a place than the average, because the way the canopy is funneling water. I'm surprised that there's as many large negative ones here, but that was another way of looking at the data. I did the same thing for the precip nitrate versus through-fall nitrate, and in that case, most of them are negative. The through-fall is dirtier than the precip. So this is so because I put a lot of work into making this data set, I shouldn't be doing all my fussing, all my analysis and stuff in this data set in case I mess it up, right? So I have an archived version of it, and you either do what Ashley said, and I just take columns out, put them into a separate spreadsheet and do my analysis, or I just have a second version of this that I do the work in, and then I can always go back. Because if you say, oh, I can always download it again from the website, but that's going way back, right? So make a working version and an archive version, and then try things out. Hide columns, figure out, how you can make things the way you want them. I think we've made a lot of progress just today in exploring these data. We found out that some of the variables are more closely related through-fall versus rain than others. We found out that through-fall is dirtier. We found out that through-fall in general is less volume than rainfall, so that the canopy is intercepting. Actually, you can see that in this one. Hold on. Because I like that relationship. I want to show that one again. Nope. Something got messed up here, Ashley. I did what I was just saying you don't want to do. I got, well, then I'm not going to, Oh, oh dear. I did. I messed up something. Sorry. So in any event, so manipulate your data, save an archived copy, and then go for it. And then the final thing I'll say, and then open for whatever questions, is I think these three basic steps of looking just at single variables and what questions can you ask just by looking at a single variable, comparing, group comparisons. We looked at just a two, but any like you might be interested in comparing your 3 classes or 4 classes, grades or interest level or whatever. That's a group comparison. It's not an XY comparison, right? Males versus females, whatever. And then the third, meaning the XY, where you're graphing one thing versus another because you think that the X variable, well, either the two might be related, which is what we consider a correlation, where you're not implying one causing the other, or where you're considering the X variable your independent variable and the Y variable is what you're trying to explain. And that's what we've been looking at, trying to explain through fall using precipitation. But we could also look at the relationship between nitrate and ammonia, or between chloride and and magnesium, or chloride and sodium, right? How do they relate? Those are all kind of graphing, XY graphing relationships. So I'm going to stop there and see, do you have comments, questions, requests?
My main question, I think you just answered, because I hadn't thought about taking students step by step through that, looking at just one variable and then having that kind of guide where they're moving to look at other data within the whole set. I think in my mind, I was seeing them kind of, I wonder how these two things are related, and I wonder how these are related, and then seeing if there's relationships and kind of piecemealing it that way. But it seems like how you took us through there made a lot of sense. Have you had experience with students? Is that typically what has worked well?
I think that each teacher that we've worked with kind of finds a different way. I think that one of the reasons why I suggest the way is that ultimately we're trying to explain variability. So by starting out by just looking at what are precipitation values, you're going to see variability and say, well, what's going on there? And hopefully you'll start asking questions about, well, why are they so variable? And what's going on? Can I explain that? And if you really wanted, like in this case, I think the most interesting questions in these data set have to do with the through fall. So then you look at through falls and wow, there's this huge range in very like some of those nitrate levels are close to toxic, right? Right? Coming at just rain. I'm out there and walking around in the rain and it's dripping on me, and it's not poisonous, but it's not safe to drink almost, right? So, and yet other times it's almost really clear, well, what's going on there, and how much of that is explained by the precipitation. In this case, we don't have different trees. We don't have data on comparing this tree species to that tree species. That's a totally interesting question that, so hopefully your students will get that sense of, here's the variability, how can I explain it? And then what are the new questions? What are the questions that I can't answer, right? And why might they be interesting? So.
Right. And my other question, I've been playing around with this today, looking at, you have Tuva linked to some of these.
Right.
And kind of seeing what would be more interesting or more straightforward for kids to use to kind of explore the data sets. And I'm not familiar with Tuba. I was just basically trying to figure it out through the course of the day today, and found that just certain data sets seemed easier to use Google Sheets and others maybe Tuba. So I'm wondering if you can shed any light on that with your experience.
So Tuba has, well, if kids are totally new to Google Sheets, then if kids have some familiarity with Google Sheets, then that might be a little bit easier for them to get started with. But because Tuba has a bit of a learning curve that's a little bit different because it's a drag and drop, and so to make graphs in Tuba, you drag things in onto axes and whatnot. But it's very powerful in especially in this kind of exploratory mode where you want to say, oh, like so the graphs that we were talking about would be easier to make in Tuba. And now that they've added some statistical, like they didn't used to have trend lines, they have trend lines now, and you can make stacked graphs more easily in Tuba. So I think that if your kids can learn, get going in Tuba, that might be an easier way to go. But we've found that, like, we have a workshop on Tuba next week, and only one person signed up for it. And last year we ran a workshop with Tuba, and only a few people signed up, and we just don't get it. We don't. I think that the places that are using Tuba, I think, are receiving just a little bit more of a sustained kind of support. I just heard a seminar by people from Maine, and the whole school system is bought into Tuba, and there's workshops and whatnot. Not to say that I think that people are necessarily doing better with Google Sheets, right? Because some of the stuff in Google Sheets is like, look, I just had trouble making a graph, right? So and so it's yeah. I don't know, Ashley, you want to comment on your observations on this, Tuba versus Sheets?
Yeah, I'll probably reflect some of what you just said, but like, if students are not, if they're kind of new to data exploration, I think Tuba is a lot less frustrating and more satisfying way to like all of a sudden see a pattern. I know of several like elementary and middle school Data Jam advisors right now who are just using Tuba for various reasons, whether they're new to Tuba or they might be a little bit behind even because of the pandemic, like everyone's a little behind these days. But, I almost recommend, if there's time for it, to maybe start with Tuba and then shift. Now that like they kind of get the hang of it, it might make sense to shift to Google Sheets for like a little bit more in-depth types of data manipulation. The downside to Tuba a little bit is that not every single one of our data sets is on Tuba. The majority of them are. So you might find that some of your students' data sets are not there, but the majority of them are. And I also just wanted to say too, like, I'm glad Alan chose like such a complex data set. Because I think sometimes students open a big sheet like this and they're like, oh my gosh, I have to work with all of these data. And you absolutely don't to have a really great project. You can choose just one variable or a couple of variables and work with those. Some of the level ones just have 2 columns. So there's so I just wanted to make that note too.
And I'll point out, like, our Data Jam, we made the assumption early on that more was better. So we kind of posted a bunch of data sets, and I didn't scrutinize all the data sets. My staff, we all, oh yeah, that sounds like a great data set. So diving into this data set, it's quite likely that the next version of this is going to be simpler and not have the complication that led me to the data cleaning step that I did. In other words, I think if we want students to look at just precipitation data with that longer record, I think that should be a separate data set. And we should only present this data that is comparable in time frame. And once you know how to hide columns or select columns, then you can do what Ashley said and just hone in on. But I'm quite interested in whether that really works and whether a data set like this is just dead in the water because it's too complicated looking. So that's part of what we're kind of always listening for in terms of the feedback we get.
And
Yeah, 20 data sets, Annie.
I know, I'll let you know because it runs I've got a bunch that have chosen level 1. I have some
Right.
who've chosen some level 3, and I have definitely told them that you're not going to look at all of the data. Don't get overwhelmed. You're just
Right,
going to,
right.
pick and choose. But this was really helpful to kind of help me to help them with a starting point
Right,
of how to start their exploration.
And I think if we can help you with some of that